In this video, we're going to learn how to do this thing here. We're going to learn how to calculate the molecular formula when we have the empirical formula and the formula mass, the MR. Okay. Now, in some problems, they won't give you the empirical formula, but using the methods we've learned in the previous videos, you can work out the empirical formula and they'll give you the formula mass and you have to work out what's the molecular formula. Now, if none of that makes sense to you, don't know what a molecular formula and empirical formula are, I suggest you go watch the video in this playlist that explains what those things are. Right, so we're going to jump into some problems over here, and we're going to do what I call side-by-side examples. So side-by-side examples are where I do one on the left, and you use the same techniques to complete the one on the right here. Now I'm just going to zoom in on the one on the right, and we're going to focus on that first. Then we're going to do one step here, and then you're going to do the same step on the right. So I suggest that you split your page down the middle and work left and right. If you want to pause the video, write down the question so that you know what the question was when you're referring back to it. Do that now. Right, now that we have the question, let's see what information we have. We have that sulfur forms a compound which has 15.8% carbon and 84.2% sulfur. It says the molar mass was found to be 481 grams per mole. Determine the empirical formula first and then the molecular formula. So we already know how to find the empirical formula when we're given the percentages. This was in the last video. So to begin with this, that's what we're going to have to do. So the first thing we're going to do is we're going to write down what elements are in our compound. Our elements are carbon, and we want to know what's the ratio of carbon to sulfur in this compound. That will tell us the empirical formula. So carbon to sulfur, these are our two elements. We'll begin by writing down the two elements. The next thing that we do is we write down what percentage of each one we have, and that information is in the question. We know that the carbon is 15.8%, and then the remainder, 84.2%, is sulfur. So that's our ratio, 15.8% to 84.2. Next thing we want to know is what's the molar ratio. So we want to convert these to moles. Now we do this by taking our percentages and dividing by the MR of the element to get the number of moles. So we're going to go ahead and we're going to do, okay, 15.8 divided by the mass of carbon, the MR of carbon. Go to your periodic table, MR of carbon is 12. Go to periodic table, MR of sulfur is 32. Next thing, get out your calculator and do those sums. 15.8 over 12 is going to give you 1.316 moles of carbon to 2.631 moles of sulfur. The next thing we want to do is write down the ratio. Showed you how to do this in the last thing. Divide both the numbers here by the lowest of the numbers. So divide by the lowest is how you do this. Lowest. Now, so we divide both numbers by the lowest number. So which one's the lowest one? Well, 1.36 is smaller than 2.631. So we're going to take both of them numbers and we're going to divide by the smallest one, 1.316, and divide this side by 1.316. Some of you out there will realize that that's, you can do that in your head pretty much. This is obviously 1, and then divided by itself is 1, and this looks perfectly like it's going to be 2, and it is 2. Now, you might get 1.999 something, but we're going to, for simple sake, we'll say that 1 to 2 ratio. So now that we know that, what is our empirical formula? Empirical formula. Well, we know here that we have 1 part carbon, C, with 1, and we have 2 parts sulfur. So CS2, that is our empirical formula. 1 part carbon, 2 parts sulfur. Let's look at your example here. So we're not finished yet, by the way. That's just the first step, finding the empirical formula. But just as a follow-up, let's see you do this one now. So what we're going to do is, it says a compound is formed of carbon and hydrogen, and it contains 92.3% carbon, and it has a molar mass of 78.1 grams per mole. What is the molecular formula? Okay, so there's a couple of extra little steps in here. The first thing we're going to do is write down what elements it contains. So go ahead and write the ratio. What elements does this contain? Pause the video, do that now. Okay, so you should have said it contains carbon and it contains hydrogen. And we want to know what's the ratio between them. The next thing we're going to do is write down the percentage of each. There's a little extra step you have to do here because it didn't give you the percentage of hydrogen. So you're going to have to work that out. So pause the video, see can you do that now. All right, so it told us we had 92.3% carbon. So 92.3 here is 2. And it didn't tell us hydrogen, but you should be able to work it out because we know we can only have 100%, so the remainder must be the hydrogen. So if you didn't know how to do that, you should pause the video and do it now. All right, so the way you do that is do 100, take away, well, 92.3. The remainder is 7.7% percent is hydrogen, 7.7%. Good. All right, so from there, you should be able to take over. We need to convert this to, we need to know the molar ratio now. So to do this, we need to take out this percentage and use the MOR to get mole. So pause the video and do that now. All right, so hopefully you did the carbon as an MOR of 12 and hydrogen as an MOR of 1. So our mole then is when we do 92.3 divided by 12, we get 7.69 is to 7.7. Okay, so that's what we're going to get there. Okay, so 7.69 to 7.7. We're going to write down our ratio. And then we're going to write down our empirical formula. So pause the video, go ahead and do that now. Okay, so we should have got that. The ratio here is going to be 1:1, basically, because if we divide these both by the same number, they're pretty much 7.69, 7.7 are the exact same. So if you divide them both by 7.69, closest numbers are going to be 1 and 1. So the empirical formula here is going to be CH. Okay, so 1 carbon, 1 part carbon to 1 part hydrogen. All right, the next thing that we want to do then is if we go over here and let's think about the next steps. The next thing we want to do is work out the MOR of we want to work out the MOR of the empirical formula of empirical. So the way we do this is we take this CS2 and we find out what would the mass or the MOR of that be. So the way I do this is work out the masses. So carbon has a mass of 12, plus there's 2 sulfurs, and each sulfur is 32. So 32 times 2. You could do plus 32, be the same thing. And when you put that in your calculator, add it all up, you're going to get 76 grams per mole. So, sorry, 76 grams per mole. So for every 1 mole, it weighs 76 grams. We have another number up here. It told us the MOR of the full molecular formula, which is heavier than the empirical formula. So that must mean there's a few empirical formulas to make up the molecular formula. So what we want to do is work out the MOR, or write down the MOR of the molecular formula. And from the question, it told us that the MOR of the molecular formula was 481 grams per mole. This is obviously bigger than the MOR of the empirical formula. You see them, compare them. Now, the molecular formula is some factor or some multiple of the empirical formula. So what we want to know is how many empirical formulas are in the molecular formula. So the way we work this out is we take our molecular formula, 481, and we see how many times grams per mole, how many of the empirical formula is in this. So we divide it by 76 grams per mole. We go ahead and divide them up. 481 divided by 76, you're going to get the answer 5. So now we can take our empirical formula, CS2, and we know that the molecular formula is 5 of these, 5 times this, which means 5 times everything in here. That's going to give you C5, S10. So we multiplied the C's by 5, multiplied the 10s by 5. So the molecular formula is C5S10. It's 5 times the empirical formula. What you have to do is you have to do the same thing over here. So we've worked out the empirical formula is CH. What we want to do now is work out the MOR of the empirical. So go ahead and do that now. Pause the video, do the MOR of the empirical formula. Okay, and what you should have got is 12 for the carbon plus 1 for the hydrogen, gives you 13 grams per mole. And now the MOR of molecular formula. And this is in the question up here. So I'm going to pause the video and let you get it, write it down. Okay, so it should be 70 78.1. And what we're going to do now is find out how many empirical formulas are in the molecular formula. So this is going to be 78.1 divided by 13. And of course, both of these units are grams per mole. Grams per mole. Pause the video and find out how many of these empirical formulas are in the molecular formula. So I'll do this sum now. Right, I'm getting a number here equals to 6.007. We're just going to round that to 6. There are 6 empirical formulas in the molecular formula. So what you're going to do now is you're going to write down for me what will the molecular formula be now that we know how many empirical formulas are in the molecular formula. Video, write it down now. What do you think? Okay, so there are 6 times the empirical formula, CH, which means you have to take the CH and multiply everything in there by 6. So you're going to get C6H6. So well done if you got that. Okay, so you see how to do that now. You always have to first work out the empirical formula, then compare the empirical formulas MR to the molecular formulas MR, and work out how many of them are in there, and you'll be able to work out the formula then. Okay, so what we're going to do is we're going to take, for your own practice here, you should take question 26, 27, and 28 and work out what it asks you to do there. And we will go through them the next day in class. So I'm just going to zoom out, get you to pause the video and work away on them. And I'll see you in the next lesson.